Welcome to Maths and Science by IITian. Today in this class I will be taking up rotation motion useful for JEE Advanced, JEE Mains and NEET Physics. Major chunk of the questions they come from mechanics. In mechanics, one of the toughest topics is rigid body motion and rotation motion. For that reason, I have taken the toughest as an initial topic, so that once you pass through the toughest, then other topics will be easier for you to understand in mechanics. I have already given sufficient knowledge regarding vectors. We extensively use vectors in this rigid body motion, and we will be using little bit of differentiation whenever that comes. For the non-mathematics students, I will give introduction to differentiation also whenever that particular situation arises, and little bit of integration, not much. And in this, in JEE Advanced also, mechanics has good amount of questions covered in it. I have prepared a question for understanding as we pass through. It is an introductory class where I will not burden you much. Definitions, notations, everything I will discuss from the next class onwards, and in this class I will be solving a problem so that you will have a feel of the rotation motion. How much ease with which you can solve the problems. It's not a very tough as people feel. If we go in a systematic way, it is an easier topic. We will move forward. What we have to find is, we have to find the omega. Omega is angular velocity of a rotating rigid body or spinning rigid body, and the axis of rotation is parallel to this vector. You are already aware of the vectors, parallel vectors, point of action, vector magnitude, cross product of the vectors, dot product of the vectors. These things are going to be helpful to you. I have given enough lectures on this for JEE Advanced level also, JEE Mains level also. I have solved the problems, and for NEET Physics also I have given about 6 lectures on the vectors. Please refer to them if you have any problems with the vectors. Vectors are essential part of learning in this particular rotation motion. They are required. Now let us go into the topic of question. The question I pose it to myself, and I made it as it is a rigid body rotates about an axis parallel to the vector so and so, and passing through the point. This vector is passing through this point. The velocity of a particle, it is a particle located at, it is a point where that particular particle is located, is given. The velocity is given. Find the angular velocity omega of the body. What is omega under these conditions? Actually, let us draw a simple isometric view of a rigid body. It is the rigid body, isometric view, and it is its axis. This axis is parallel to some vector, that vector is this, and passing through the point. It is passing through some point here. That point is I plus j minus k. I am not doing it in a 3D so that I can't represent totally I plus j minus k, but you will visualize or you draw an isometric view and you find out. And you draw, better you draw with your own hands. Whether it is a small problem or a bigger problem, if you draw and solve it, while learning, please spend time. While solving the problems in the examination, you may be faster, but while learning, please spend time. Please work on the problem. This is the point, and this vector is parallel to, that means this vector we can say 2i minus j plus 3k. The velocity of a particle located, a particle is located here, it has got a velocity v 25 by square root of 14. Because velocity is a vector, it will be in ijk, I plus j plus k. All are vectors here. Axis is a vector, point is a vector, and the velocity is a vector. Particle is located, this is the particle where it is located P, it is a vector 4i plus 2j plus k. This is how you have to draw the diagram. This is the rigid body. Rigid body. It is spinning. Spinning means rotating. Spinning or rotating. It is rotating with omega. And we have to find this omega, angular velocity. Let us try to find. Let us dwell into our real vectors. Using vectors, how to find out. You know, one particular equation you have to know in rotation, motion, that is V is equal to R cross omega. Cross. Please remember, don't change the order. Don't change cross to dot. It is a vector. You please make a note that it's a vector. What is that vector? It is given V bar is equal to 25 by square root of 14 minus I plus j plus k. Now, what are the other data given? Other data given is particle position. This is one data, another is particle position. at P as I shown you previously. What is the particle position? 4i plus 2j plus k. Go slow, nothing to worry. Let us not hurry while learning. A point on the axis is equal to I plus j minus k. And the axis is parallel to the vector. These are all given. Axis is parallel to the vector two I minus j plus 3k. Therefore, angular velocity, we are moving slowly, don't worry. Angular velocity vector is equal to magnitude of omega, because omega we are not knowing, we have to find out omega, magnitude of omega into, not into, magnitude of omega and unit vector of the axis. Because you see, this is the axis and omega is like this is the axis, omega is like this, then omega will be its magnitude into unit vector in the direction of this axis. N. This is magnitude, and omega is equal to, vector omega is equal to magnitude omega into magnitude omega of, with unit vector n in the direction of the axis. Please try to understand. Then axis is parallel to this, and what is the unit vector on the axis? Unit vector on the axis is equal to, because unit vector parallel to the axis or on the axis will be same. Unit vector is vector divided by its magnitude, that I have told you many times. What is this vector? 2i minus j plus 3k. Whole divided by square root of 2 square plus 1 square plus 3 square. that is square root of 14. 2i minus j plus 3k divided by square root of 14. This is the unit vector on the axis. Unit vector on the axis into magnitude of omega times unit vector is equal to vector omega. This is what is to be found out. Okay, you got this. Now, we know the relation V is equal to R omega. V is given to us. V is equal to R cross omega. R is nothing but the distance between the displacement between the particle position and point on the axis. Because it is a point on the axis, particle position is here, point on the axis is P dash, and with reference to origin, OP and OP dash are given. This is OP. OP is how much? Particle position is how much? These are all with reference to origin. Particle 4i plus 2j plus k. OP dash is how much? Point on the axis. Point on the axis is I plus j minus k. And what will be PP dash? I have many times told you, in the last class also I told you, PP dash is equal to PO plus OP dash. This O is common in between. PO is nothing but minus OP plus OP dash. Or we can say it can be P dash P also. Either way we can see. Because omega is required this way, basing the with respect to axis we require and a point on the axis, because omega is this way, and with respect to point on the axis we require PP dash, not P dash P. We require with respect to this, because this is the axis, this is the N, and P dash P is equal to P dash O plus OP dash, that is equal to OP dash minus OP minus OP dash. What is OP? 4i plus 2j plus k minus plus j minus k. What is that? Point I plus j minus k. I plus j minus k. You should be very careful in writing this. This is very important. With practice only you will get it. PP dash is equal to 4i minus I is 3i plus 2j minus j is plus j plus k is 2k. I think this is pp dash. This is equal to r. Distance between the point and the particle. That is r. That is the displacement between the point and the particle. And what is v? v is equal to r cross omega. Omega still we are not aware. What is omega? R is, we know, 3i plus j plus 2k cross magnitude of omega of, what is that? Unit vector. Unit vector is 2i minus j plus 3k. Here for clarity we will write like this. What is v? v is known to us. What is the velocity v? Linear velocity, that is 25 by square root of 14. 25 by square root of 14 times minus I plus j plus k is equal to W, we are not aware, magnitude of W square root of 3i plus j plus 2k cross unit vector is 2i minus j plus 3k. This is the equation which we have to solve and we will get the answer. We can cancel root 14 and then we get 25 into minus I bar plus j bar plus k bar is equal to magnitude of W into cross product of these two, unit vector and this one, r. R is there, unit vector is there. We have to cross multiply. What it means? It will be ijk 312 r omega we have to do. R is 312. Omega is 2 minus 13. This implies we will get answer as you solve this. This is your homework. Let's not waste time on this. I have given the sufficient concepts to you. This yields result 25 into minus I plus j plus k is equal to omega into 5 into minus I plus j plus k. That shows omega is equal to magnitude of omega is equal to 5. The magnitude of omega is 5. The actual value of omega as an angular velocity, that is equal to 10i minus 5j plus 15k divided by square root of 40. This is the omega as a vector, and magnitude of omega is equal to 5 radians per second. These are the answers. Now, with this, I want to conclude with a small brief that if there is a body, rigid body, it has many particles in it. In the other topics like laws of motion, conservation of momentum, conservation of energy, we treat everything as a particle. Particle means very small teeny matter, and we treat a bigger mass also as a particle, 5 kg mass also as a particle. Whereas in rigid body, particles will be lying on the rigid body. We will be taking the rigid body as a whole. Rigid body sometimes we will not treat it as a particle. It has a body with mass. It has a body with dimensions. Hence, we enter into the topic of moment of inertia. Because a body, a particle will not have moment of inertia. It's a very small. Whereas a body having dimensions will have moment of inertia. Hence, we enter into the topic of moment of inertia and we do all those things, and it is the beginning, and I have taken a very small example, simple example, rotation motion, where a body having an axis like this, rotating about this axis, this is having n as the unit vector, and about the axis it is rotating with omega, and at a particle p the velocity is taken as tangent as v, and a particle position is taken as p here, and a point on the axis is taken as p dash, and we have found the angular velocity. If you have a body diagram like this, it will be easier for you to understand the concept and solve the problem instead of reading the theory. Best of luck to everybody. In the next class, I will start with the prelims. What is r omega, what is v, why it has come, and what is angular velocity, what is linear velocity, what is momentum, angular momentum, everything we will discuss in detail from next class onwards. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my video. I am from Maths and Science. It's my own channel, Maths and Science by IITian. Please subscribe to my channel if you feel there is a value addition to your knowledge, and please share my videos. There are many videos on mathematics and also in the physics section. I deal with two sections. One is mathematics by IITian in the same channel, and physics by IITian. My mathematics is good up to JEE Advanced level, and my physics will also be up to JEE Advanced level starting from